Hi, thanks for sending your question. So in number 20, we are given a pair of points, an x-coordinate and a y-coordinate, and we are told that this is a solution to a direct variation. And we have three things we have to do. The first thing we have to do is write the equation of direct variation. Then we're going to graph our solution and show that the slope of the line is equal to the constant of variation. So how we're going to do that is we're going to go step by step here. So let's start on step 1. We're going to write the general equation of direct variation, and we're going to plug in our coordinates. Well, if there's a direct variation going on, then that means that whatever's going on follows the equation y equals kx. So it's a line with a slope of k and a y-intercept of 0. We need to solve for k. To solve for k, we have to get k by itself. So to get k by itself, the first thing we have to do is plug in our coordinates. Let's go ahead and do that. When we plug in 2 for x and 10 for y, this will be a true statement, is what they're telling us. So I just directly plugged in my x-coordinate and my y-coordinate as they were given to me. K is now almost by itself. Let's get it by itself by dividing both sides by 2. 10 divided by 2 is 5. So it looks like 5 is equal to k. So we've now done step 1, and step 2 was solve for k, the constant of variation. Now we've done step 2 as well. Let's do step 3. We're going to input our solution for k, which is the constant of variation, into the equation, and we're going to rewrite our equation. So instead of y equals kx, for this specific situation, what I have going on is y equals 5x, because 5 is equal to k. Step number 3 is done. Now let's go ahead and graph what's going on here. So this is a line, y equals 5x, and it has a y-intercept of 0. So we're going to start at 0. The slope is rise over run. So 5 is the same thing as saying 5 over 1. So the rise is 5, and the run is going to be 1, which means I'll start from 0, 0, go up 5, 1, 2, 3, 4, 5, and over 1. And then I'm going to go ahead and connect these points here the best I can. It's a little difficult to draw a straight line in this program, but I think you get the idea. Go ahead and graph your second point using the rise over run, and then connect the origin and that point. So that is what our direct variation looks like when it's graphed. And the last thing we're supposed to do is show that the slope of this line is actually equal to the constant of variation. Well, that's a pretty obvious statement at this point, because we got this slope, the slope being 5 for this line, by solving for k in the first place. Meaning we wrote y equals kx, solved for k, and plugged in k. So it does follow that the slope of this line, this particular line that we're graphing right here, is going to be the same as the constant of variation, k. And that's the end of the solution. Thanks for sending your question in again, and I look forward to answering more of your questions using SnapMath in the future.